Hello! We haven't spoken in a while, so I decided to return with a video about the DCM 1.2 ECU, which is also found in the Renault vehicle range. The car had been to several service shops where they replaced the high-pressure pump regulator, 2 injectors, and whatever else they might have changed, but the car still wasn't running well. On the diagnostic tool, besides the error on the glow plug circuit, it also had 2 other errors, DF071 and DF137, related to the accelerator pedal and the fuel pressure regulator. Well, the symptoms of the malfunctions were a very long, annoyingly long start, lack of accelerator pedal response, rough idling, and stopping while running. So, I suspected a problem with the ECU. I removed the ECU and thought that before opening it to check for cold solder joints, it would be good to make a backup. But I made a mistake, which I am showing here in the hope that no one else repeats it. I wanted to copy the flash memory first, so I drilled a hole in the plastic cover to reach the boot pad. I had to cut the plastic cover anyway to copy the EEPROM, but I decided to start this way, with the hole for the boot pad. Unfortunately, I dropped the drill bit inside onto the board and destroyed the 95160 EEPROM memory and the circuits on the board. So, I replaced the ECU. Now, I will show you the steps to avoid repeating some of my mistakes, depending on what you want to do: flash backup, EEPROM backup, virginize ECU, or checking for cold solder joints. On the DCM 1.2 ECU, the SA95160 EEPROM memory is located on the side with the plastic cover, according to the location shown in the image. To copy and write the ECU's flash memory, you can drill a 6mm hole in the area colored yellow in the image. The coordinates of this point, measured from the edges of the ECU, are approximately 65mm from the right edge and 38mm from the bottom edge. Be careful when drilling not to press too hard, causing the drill bit to enter too far inside, as you risk destroying the circuits and electronic components on the board. If the SA95160 EEPROM memory needs to be copied or written, a rectangle must be cut into the black cover, exactly in the area of the EEPROM memory. Alternatively, you can cut the plastic cover along the line drawn in blue in the image, from one side to the other. This exposes a larger area of the PCB inside the ECU. Next, I will show you how I performed these operations, with brief explanations where needed, and towards the end, you will also see the cold solder joint check. I found a spray can cap, which I used as a stopper, to prevent the drill bit from going too far inside and damaging the ECU. I drilled the hole and through it, you can see the pad inside for putting the ECU into boot mode. In the image, you have the pinout for powering the ECU and copying the flash memory. The gray-colored pad can be accessed either through the hole or through the cover cut in the EEPROM area. In the ECU software, I chose boot mode, SA10F280, put the ECU into boot mode, and read the flash memory. Next, you will see how I cut the plastic cover to be able to solder and copy the SA95160 EEPROM memory. Using a small tool with an abrasive blade, I cut the plastic cover very finely, according to the diagram, approximately a rectangle with sides 45 by 40 millimeters. Finally, with a screwdriver, you remove the cut piece without destroying anything inside. Here you can see the boot pad, and to its right, the 95160 EEPROM memory, which will need to be desoldered from the board for copying. Since I did not open the other side of the ECU, which is aluminum, desoldering the EEPROM will be more difficult because the aluminum draws heat away from the PCB. The aluminum side must be opened if the PCB needs to be exposed in the area where the pins of the ECU connector are soldered. By removing the aluminum cover, the EEPROM memory will solder much easier, as it will be without a heatsink. Here you will see the desoldering of the EEPROM memory with the heatsink mounted, and later in the clip, the soldering of the memory with the heatsink removed. I placed the EEPROM in the programmer, selected the SA95160 memory, and saved the file to the computer. To virginize the EEPROM, edit the memory in hexadecimal, from address 00 to address 18, with FF. With this modification, the immobilizer will authorize the car to start. The injector codes will need to be rewritten, so it would be best to copy them beforehand, ideally with a diagnostic tablet. Next is the removal of the aluminum cover to expose the area where the ECU connector pins are soldered to the PCB. Heat the aluminum heatsink with a gas torch or a hot air soldering station. Be careful not to burn yourself, as everything becomes very hot. Before that, you must drill out the plastic rivets, which also hold the plastic cover to the aluminum cover. When closing and sealing the ECU, besides silicone, for screws and nuts will also be used, which will be placed in these holes. Be careful not to injure yourself if you follow this procedure. You can use high-temperature resistant gloves to handle the ECU. After the aluminum reaches a sufficiently high temperature, a screwdriver is used to remove the silicone and carefully pry open the aluminum cover. Between the PCB and the cover is a thermally conductive adhesive that transfers heat from the board to the aluminum cover, thus cooling the board. Finally, we reach the connector pins and the troublesome solder joints. Due to mechanical shocks and temperature variations, the solder joints weaken, and the solder no longer makes proper contact on the pins, leading to an imperfect contact or an open circuit. This situation leads to the poor function of vital components commanded by the ECU, either intermittently or permanently, ultimately resulting in a waste of time and money. In the image, you can see the cracks in the solder that have appeared around the pin. I redid the problematic solder joints. It is advisable to resolder all the pins. The SA95-160 EEPROM memory solders much easier onto the board now, considering the heatsink is not yet mounted. When soldering, care must be taken that pin 1 is in the correct position and that all the EEPROM pins are aligned and soldered to the pads. I cleaned the remaining silicone very well from the covers, put fresh silicone on the groove of the aluminum cover, and glued the covers together. Finally, I also glued the cutout rectangle back onto the plastic cover, put the ECU back in the car, connected the plugs, rewrote the injectors with the Autel tablet, and that's it. Everything works perfectly. For this error, the injector codes must be rewritten using the diagnostic tablet. I know, the first two codes are the same, that's how they were written in the ECU I initially damaged. I took the photo of the codes during the car's first diagnostic check. In conclusion, if you are dealing with a DCM 1.2 from the Renault range, also consider the problem of cold solder joints in the ECU. If you open the ECU, be careful not to damage it worse than it already is. Take photos of the injector codes and back up the EEPROM and flash memory. You will need them if you have to replace the ECU. Thank you for watching. Please like the video and subscribe.